In this topic, we are going to look at vector subtraction. First, let's look at what negative vectors are. A negative vector of vector A is a vector that has the same magnitude as vector A, but is in the opposite direction of vector A. If we name vector AB as A, then vector BA will be equals to, yes, it will be negative A. Therefore, AB is equals to the negative of BA. If AB is in this direction here, then BA will be in the opposite direction. Now, which of the following vector is the negative vectors of vector A? Yes, vector FE is the negative vectors of vector A because it has the same magnitude but is in the opposite direction. In the grid below, we are asked to draw another line segment for negative B and negative C. Hence, we have to draw a line segment that is of the same magnitude but is in the opposite direction. Once again, the position of a vector is not important. Therefore, you can draw it anywhere in this grid space as long as the direction is opposite of B and it has the same magnitude. Likewise, for negative C, it will be in the opposite direction and it will have the same magnitude as vector C. Now let's look at vector subtraction. First, we recall that vector AC is equals to the negative vectors of CA. And these two vectors are opposite vectors. Likewise, vector CA is equals to negative vector AC. Subtraction of vectors is simply the addition of negative vectors. Vector PQ minus vector RQ is the same as writing vector PQ plus negative vector RQ, because positive multiplied by negative will give us negative. And so, subtracting of vectors is the same as the addition of negative vectors. Now, negative RQ is the same as QR, and therefore we have vector PQ plus vector QR. Once again, do recall that vector QR is equals to negative vector RQ. And since these two letters are the same, therefore we have a continuous path and the resultant vector will be PR. Simply put, vector PQ minus vector RQ is equals to vector PQ plus vector QR, which will give us vector PR. In this example, we are asked to express vector AB minus vector DC minus vector CB as a single vector. We will change the subtraction of vectors into addition of negative vectors. Now, negative DC is equals to CD and negative CB is equals to BC. And we can rewrite the vectors in this way. Now, you notice that these two letters are not the same. Similarly for these two letters, and hence we cannot add the vectors directly. What we can do is to switch these two vectors around to give us vector AB plus vector BC plus vector CD. Since these two letters are the same, the resultant vector will be vector AC plus vector CD. Likewise, these two letters are now the same, and we will have the resultant vector AD. Next, let's look at 0, or what we call null vectors. This diagram here shows a regular hexagon. We are asked to state all the vectors that are equal to vector BO, which means that we have to find vectors that are having the same direction and the same magnitude. And we will have vector AF equals to vector BO, vector OE is equals to vector BO, and vector CD is also equals to vector BO. Hence, we are asked to express vector AB minus vector DC plus vector XA as a single vector. we will change this subtraction of vector into addition of vectors. And we will have vector AB plus vector CD plus vector XA. Now, this is vector AB, and this is vector CD, and this is vector XA. You notice that vector CD is not in a continuous path as the other two vectors. Therefore, we will use vector BX instead, and we will have vector AB plus vector BX plus vector XA. Now, since these two letters are the same, we will have vector AX plus vector XA, and likewise these two letters are the same. And what will we have for the final answer? We will not write it as vector AA. Instead, we will write it as a 0 or null vector. A 0 or null vector is not a directed line segment. It is actually just a point here. It has no magnitude and no direction. And now a 0 vector is the only vector without magnitude and direction. Vector AO plus vector OA is equals to a 0 vector. We have vector AO plus vector OA will simply result in a resultant vector, that is the starting point. If vector OA is equals to A, then vector AO plus vector OA is equals to negative A plus A, which will give us 0 vector. In this next example, vector OA is equals to A and vector OB is equals to B. We are asked to express vector OC in terms of A and B. Since vector OC is equals to vector AB, therefore vector AB is equals to vector A blank plus vector with a blank B. Yes, these two letters must be the same letter. Since vector OA and vector OB are given, we will use the letter O. And vector AO plus vector OB will be equals to vector AO is equals to negative vector OA. And hence we will have negative vector OA plus vector OB, which will give us negative A plus B. In summary, a negative vector of A is a vector that has the same magnitude but is in the opposite direction of vector A. And vector AB is equals to negative vector BA. The subtraction of vector is the addition of negative vectors. And we can write vector PQ minus vector RQ as vector PQ plus negative vector RQ, which can be further simplified as vector PQ plus vector QR. Finally, a 0 vector or null vector is a vector with no magnitude and direction, and it is represented by a 0. And that's all for this topic.